Alright, this is the test correction video for the green test. So, starting with number 1, we have a position time graph, and it says, in an experiment, an object is moved along a straight line with different types of motion. The graph above shows position versus time for the object during the first 3 seconds of its motion. Which one of the following is closest to the average speed of the object between, whoops, I accidentally put between and during. No, let's do during, makes more sense. During the first 3 seconds. So I need the average speed of the object in the first 3 seconds. I know this is kind of a weird slope, it's not constant, but the average speed will be the slope of the entire line. Okay? So I would do y2 minus y1, so 4 minus 0, divided by x2 minus x1, 3 minus 0. If you think about it, it covered 4 meters in 3 seconds, so it's really just distance divided by time, which is why the slope of the line works, because it's the equation for velocity. So 4 divided by 3 is 1.3 meters per second. Okay, which of the following pairs of graphs cannot possibly be describing the same objects? Cannot be describing the same objects. Okay, so here we have a position time graph, but we have it for as far as the slope goes, we have a decreasing positive velocity. So here we have a decreasing positive velocity. Here we have a decreasing positive velocity again. Still, we need a decreasing positive velocity. So those two graphs aren't matching those position time graphs. Here we have a constant positive velocity. Is that a constant positive velocity? No, it's increasing at a weird rate. Here we have an increasing positive velocity. Okay, this right here shows a constant acceleration, right? Increasing positive velocity at a constant rate. This is not a velocity increasing at a constant rate. So these two will never look identical unless this one's at rest at 0 and speed is at rest. So that's the only time they look identical. So note of that one. Increasing positive velocity, increasing positive velocity at a constant rate. So our answer here would be E. Let's see here. I don't see that answer. Let me reread the question. Which of the following pairs of graphs cannot possibly be describing the same? Oh, sorry. I read the question wrong. This is the only one that could possibly be describing it. It's a good thing I didn't have this as an answer down here. This is the only one that could be describing the same object. So A, B, C, and D cannot be describing the same object. A, B, C, and D. Oh, gotta read those questions carefully. Okay, which one cannot be describing? So this is the only one that could be describing. Okay, number 3. We have the graph to the left shows velocity versus time for an object in linear motion. Which of the following is a possible graph of position versus time for this object? Okay, the graph to the left shows a velocity versus time. Which of the following is a possible position versus time? So we start out with a constant positive velocity. So on a position time graph, that's going to be a constant positive slope, right? Then we have a decreasing positive velocity. So on a position time graph, that's going to be a decreasing slope. Then we have an increasing negative velocity. So on a position time graph, that's going to be an increasing negative slope. Okay, and then we have a constant negative velocity. So that's going to be a constant negative slope. Okay, I hope that hasn't confused you. I've done that a little bit differently. Let me put that closer to the camera. So here we have a constant positive velocity on a position time graph, constant positive slope. Here we have a decreasing positive velocity, so on a position time graph that would be a decreasing positive slope. Here we have an increasing negative velocity, so that's an increasing negative slope. followed by a constant negative velocity, constant negative slope. So if I put all of these together, let's just try that. Constant positive velocity, followed by a decreasing positive slope, constant positive slope, followed by decreasing positive slope, followed by increasing positive slope, followed by constant negative slope. This is the only one. I've never tried doing it that way, but that works. Works quite well. Okay, so there's A. The answer is A. Okay, number 4. The graph to the left is a plot of a position versus time, for which labeled region is the velocity negative, so that means we have to have a negative slope, but the acceleration is positive. Okay, so if the acceleration is positive, but I have a negative velocity, let's look at these two. If I have a negative velocity, the only way to have a positive acceleration is if I'm slowing down. In the negative direction, slowing down will give me a positive acceleration. So I need a negative velocity, but since I'm slowing down, and this right here represents velocity, the slope of the line represents velocity, I need a negative slope, but I need it to be decreasing. A negative decreasing slope is a negative decreasing velocity. So I can only choose between B and C, and you can see B is an increasing slope, increasing negative slope, and C is a decreasing negative slope. So we're going to have to go with C on number 4. Okay, number 5. Shown below is the velocity versus time graph for a toy car moving in a straight line. What is the displacement of the car in the first 1.5 seconds? So here's 1.5 seconds. I've got to find the area of all of this. Okay, that's quite a feat here because I don't know any equation for that. So I'm going to find the area of this rectangle, and then I'm going to add it to the area of this triangle, and then the area of this rectangle. Okay, so as quick as I can, let's see here, from here to here, that's going to be base times height, right? So that's half a second from 1 to 1.5. So that's half a second times the height is 4 meters per second. Seconds cancel, so 1/2 times 4 is 2 meters. Okay, let's do this portion. Okay, my base is a whole second high. Of course, this is a triangle, so I'm going to put in a half. 1/2 times the whole second, so times 1 second, times the height. It goes from 2 to 4, so that's 2 meters per second high. Seconds cancel. 1 times 2 is 2, and 2 times a half is 1 meter. Okay, and then the last one, a rectangle, it's a whole second long, times the height, 2 meters per second. Seconds cancel, and I get 2 meters. So 2 plus 1 plus 2 is 5 meters. So it must have traveled 5 meters. So my answer to 5 must be B. I calculated the area of 2 rectangles and a triangle. That's why I have the half here. 1/2 base times height. Added all those together, and that's the displacement. Okay, watch video 2 for the rest.